This video is going to show the disassembly of a Shurflo diaphragm pump which we use for our camper van, because we had a problem with it. The motor wouldn't start, there was no sound when you turned it on whatsoever. So either the fuse was blown in the switch or there was something more serious wrong. So firstly we checked if the fuse was blown with our trusty friend the multimeter, by connecting the red terminal and black terminals to the power supply red and black terminals of the pump, which I can show you. Our red terminal power supply 12 volts is here, so down from here, and the ground terminal plugs into the top of the motor. So we made sure we had the voltmeter across those two terminals and had the voltmeter set to DC volts, and it read 12 volts. Whoopee! So it's getting power from somewhere. However, the motor doesn't directly get 12 volts from there. It actually goes through a switch in the lower part of the housing. So what happens actually is that when there's high pressure inside the pump, it turns off the motor. So there's a little diaphragm which pushes up, and there's a mechanical switch that pushes down and actually breaks the connection between this terminal and this wire, between these two wires. So normally these two are connected, but otherwise they're not. So we also checked that the voltage between this terminal and the black ground terminal, as I said from the top of the motor, was as expected, so greater than zero, well, much greater than zero, something like 11 or 12 volts, just in normal operation. And when you press the switch, and you can actually do this mechanically yourself by going like this, so when you press down, it should turn off that connection, which it did. So our multimeter reading went down to millivolts rather than 12 volts, which is basically zero. So great. So the check switch, I think it's called a check switch, was working fine, which meant the motor was working fine. So next step was to look inside the motor. Well, first we sort of looked inside the rest of the pump. So we took out the rest of the screws, the lower part, the housing, and then this part. So you can see the crankshaft from the motor that turns around, and how can I show it in here? I take this off. Woo! There we go. Okay. So these are the three diaphragm chambers, and basically the crankshaft spins round, and as it spins round, it kind of pressurizes each chamber, so the water sort of pumps round. Shut up, multimeter. Pumps round and from the inlet to the outlet. But as we know, the motor isn't turning at all. And when we tried kind of moving the crankshaft ourselves, it didn't move. So maybe it was rusty. Maybe there was something causing it to not move. So if that's the position you're at, then maybe a good idea would be to have some high viscosity grease and put a dab of it inside here, and check that the connection here isn't stiff, isn't rusty, because it might be. That was our problem. Because inside here you've actually got ball bearings, and they kind of sort of connect with the shaft of the motor, and we could feel the kind of rust kind of crunching as we moved it over. But actually what we did is we took out the whole motor, and you can actually do that yourself by unscrewing here, and you pull out here where you see the connections from the power supply to the motor shaft, and then you can pull out the motor from the bottom. There's another video that shows this complete disassembly, but I'm not going to do it here. It takes a bit of effort to take it out from the bottom because there are big magnets inside which keep holding it in. And in the housing up here you'll find that you have, as well as the power supply, you have some decoupling capacitors. You also have between the power supply and where the red wire, where the power supply from the positive terminal goes to the motor shaft, you have a what is it? It's called a snap action self-hold thermostat. Basically, it's a little thing that looks a bit like this, like that, and it's a snap action self-hold thermostat for motor and appliance applications. In a fault condition, the Model JS opens the circuit and an internal heat source holds it open until power is removed and the unit is allowed to cool. The thermostat then resets, allowing continued operation. Basically, when it gets too hot, it turns the motor off, and when it gets cool again, it turns the motor back on. And that component is a thermal cutout switch, I think it's called, Model JS. And yeah, so we put it back together and everything worked, which we can show you. So we have a big car battery just to test things on, and I made a kind of makeshift way of clamping it to the battery terminals. Sorry, not the battery terminals, the pump terminals. So where is it? So we've got the red one, clips onto here. This is kind of quite bad with crocodile clips, but yeah, that's all we had. And the other one, not very secure connection, but it's only for testing. And then positive terminal and negative terminal, and the battery works. And you can see if you press the diaphragm, it turns it off, because the little switch turns it off, which is nice to know. Yeah, and that sort of concludes the video.